human body is a very serious matter. So, how does this fit in? It's actually a reference to the focus of this episode, our kidneys, which make urine. These vital organs are found slightly above the waist. They're tucked out of sight, so they're easy to ignore. They're not very big, but recently, there's a place that can help us understand the power of our kidneys. It's a beautiful plateau, 2,100 meters above sea level. These people belong to one of Japan's top swimming teams. They didn't come here for the view. Still not sure about the value of these incredible organs? Perhaps this next story will change your mind. It highlights their role in curing a common but very deadly disease.
Kidneys are a very important organ in body cross-talk. They are connected to all other organs, and they are responsible for our fluid balance and fluid control, and certainly they're one of the main control organs for our blood pressure.
Our bodies contain a vast, complex network for exchanging vital information. Kidneys are the key node in that network, transmitting a range of molecules that deliver health-related messages. They may be the most important organ in the entire body. Why is that? The kidneys emit EPO to control the number of red blood cells, and renin to regulate blood pressure. Both jobs are essential to our survival. But how did the kidneys end up being so important? You'll learn the answer after discovering the true role of kidneys. Our bodies are crisscrossed by a network of blood vessels. Their combined length comes to about 100,000 kilometers.
2.5 veces la circunferencia de la Tierra.
Blood vessels are transportation routes that carry oxygen and nutrition and collect waste. They are also used to deliver messages from organ to organ. Look closely, and you'll see that the network of blood vessels is particularly dense in the kidneys. In fact, 1/4 of the blood that passes through the heart is sent to the kidneys. Why do the tiny kidneys receive so much blood? It is because they control the way blood functions in our bodies.
En 5 minutos toda la sangre del cuerpo
As we've already seen, they're involved in regulating red blood cell levels and blood pressure. But they control other things as well. The kidneys actually regulate every component in the bloodstream. The various components of the food we eat are absorbed by the stomach and intestines, and then enter the blood. They include sugars and minerals such as sodium and calcium. If these components go below or above the appropriate range, serious problems can occur. Take potassium, for example. This mineral, found in bananas and other food, is important for maintaining good health. However, too much potassium in the blood can cause deadly changes to your heart. When healthy people eat bananas, the amount of potassium in their body remains fairly stable. The kidneys keep everything in balance. They automatically and superbly adjust various components of the blood. Kidneys keep our blood under control, but how? This image from a live kidney was captured from an 8K microscope. The blue parts are a cross-section of the renal tubule. Blood is shown in red. The blood component adjustment process is underway. The kidneys never slow down, much less take a break. These hard-working organs have yet another surprising function. The kidneys do not decide by themselves which components get adjusted. They listen to messages from other organs and include these messages in their decisions. The kidneys lower the amount of sodium being absorbed and expels it in urine. That's because less sodium means lower blood pressure, which makes it easier for the heart to do its job. The kidneys read the many messages from their fellow organs and create the most suitable conditions for the entire body. So does this make more sense now? The secret of the kidneys lies hidden in the way urine is formed. The kidneys are key nodes in the body's network and control everything that happens there. Let's hear it for urine. People around the world are becoming more aware of the role kidneys play in keeping us healthy. But one scientist helped lay the foundation for these discoveries many years ago. He is Takaji Miyake, a legend in the field of kidney research. Makoto Kawakita worked with him. The two doctors specialized in blood research. They believed that the kidneys released an important molecule that controlled the red blood cells. They began searching for it in the 1960s. That molecule is EPO. It transmits messages that are essential for delivering oxygen throughout the body. How did they discover it?
ですね、患者さんの尿、貧血の患者さんの尿から取り出すと、この部分が尿ですね。
However, it wasn't the easiest job in the world.
低温室で処理するんですけどね、時々低温室が故障すると先が匂いですね。それと、やっぱりしぶきを吐きますんでですね、夏なんか特に医局の女性なんかには、実はおしっこ臭いとか言われましてですね。
They processed urine and conducted experiments every day for more than 10 years. Until they successfully extracted EPO for the first time in the world. They went through a lot of urine.
最終的に処理した量は2リットルも毎日毎日10リッターとか15リッターとか尿を処理するんですけど、結構時間かかりまして、はい、もうしょっちゅう午前騒ぎになってました。医局に寝転がって目が覚めたということもありますね。はい、大変だったですよ、
But 10 years after this discovery, their efforts came into fruition. Analysis of EPO they extracted led to a synthetic version, a life-saving medication. Diseased kidneys have difficulty creating EPO. That causes the volume of red blood cells to decrease significantly, resulting in severe anemia. Drugs containing EPO are saving an estimated 2 million patients worldwide.
9回ありました。最近ですと月に1回でいいようなお薬も出てきていますので、患者さんにとってはかなり楽に治療を受けられるようになっています。
Recently, scientists have made another significant discovery related to EPO. This is Norio Suzuki of Tohoku University. Where does EPO come from within the kidney's complex structure? It's long been one of the great mysteries in medicine.
Delegando suprarrenal.
Suzuki was the first in the world to solve it.
これは間に光る細胞が、これが
EPO producing cells hide around the renal tubule that regulates components in blood. The tubule consumes significant amounts of oxygen as it carries out the critical task of reabsorption. Therefore, in the area surrounding the tubule, oxygen tends to be in short supply. The kidneys take advantage of this extreme situation to check oxygen levels in the entire body.
低酸素になった時にその影響が一番大きく出るそういう組織なんですね。そこでの低酸素の感知というのが全身の低酸素感知に非常に役に立つ都合がいいというそういう構造だというふうに考えています。
The more we learn about kidneys, the more we appreciate how well they're made. Scientists around the world continue to study their incredible powers. Next up, we have another important discovery to tell you about. Our kidneys determine how long we will live. Our kidneys have become more and more complicated over the long process of evolution. After animals emerged from water, it became increasingly difficult for them to maintain the proper proportions of various components in the blood. The human kidney has evolved into an organ with an extremely strong ability to keep those components properly balanced, and that helps account for our relatively long lives. Humans have flourished not only because of our brains. Our kidneys are also an essential part of what makes humans human. We know that preventing acute kidney injury and protecting the kidneys are necessary to ensure the health of all organs.
治療に使う薬剤というのは腎臓を通して排泄されていくわけです。そうすると腎臓が悪くなっていきますと排泄が悪くなって副作用が出やすくなるということはそのお薬を使うのを減らさなければいけない。他の臓器の治療が腎臓が悪いことで不十分になってしまう可能性がある。腎臓はやはり臓器のネットワークの要ですので腎臓を守るのはとても重要だと考えています。
Following this hospital's example, 10 more UK facilities have begun to explore implementing a similar system.
Organ crossover, this dependence on one organ or another, is a phenomenon, particularly in critical care, that we're becoming increasingly aware of. There are so many things that kidneys do that people are just not aware of. And so this fine balance of this fantastic piece of engineering is vitally important. And when they fail, patients are doomed to early death and numerous complications.
A new era of medical treatment has begun, one that considers the human body as a network focused on kidneys.